Hi there! This video series is to display my problem-solving and learning abilities. I plan to show that I can solve any programming problem, regardless of whether I already have expertise in a particular language. I hope this helps others in my field to learn not just how to solve a particular problem, but how to teach themselves a solution to an unfamiliar problem. Currently, I am learning Python. I have no professional experience in the language and have only been learning it since mid-January. My only formal training is completing the Python for Programmers course on Execute Program. While I'm picking Python up fairly quickly, I cannot claim any real expertise. Today, I am showing my approach to solving the 38th Project Euler problem from start to finish, vocalizing my thought process throughout. As always, I will link to both Project Euler and my repository in the description. You may have noticed that there is a problem 38 answer here, and that is because yesterday I recorded my solution, but did not check it, and there was no sound on the video file, so we're just gonna do it again. So let's go ahead and dive in. Problem 38 is Pandigital multiples. Take the number 192 and multiply it by each of 1, 2, and 3 to get these results. By concatenating each project, we get to the 129 Pandigital. We will call that the concatenated product of 192 and 123. The same can be achieved by starting with 9 and multiplying by 1, 2, 3, 4, and 5, giving the Pandigital that, which is the concatenated product of 9 and 1, 2, 3, 4, 5. What is the largest 1 to 9 Pandigital 9-digit number that can be formed as the concatenated product of an integer with 1, 2, up to n, where n is greater than 1? Okay, so obviously we have the answer right here, but what we're going to do is we're going to go to our code. I've gone ahead and deleted everything that I did yesterday, and I'm just going to recreate it. So we had a different Pandigital problem back in problem 32. And in this case, it was finding the sum of all products whose, like, multiplicand, multiplier, product identity can be written as a 1 through 9 Pandigital. So it was like the string version of those has 9 digits, and each of those are there. So we're just going to go ahead and take all of the code from problem 32, put it here in problem 38, and then make modifications. And in this case, we want we actually want just the largest number, so we don't really care about storing all of them like I have done previously. And in this case, we're going to have concatenated equals an empty string. Here, I'm going to start with 1 and go up to 10,000, because most likely that's where the correct answer is. And then I'm going to do 1 up to 10 here, and we want concatenated equal to concatenated plus the string representation of p, and then if the length of that is equal to 9, we think that might be correct. And actually, we don't even need this add equals true, add equals false here. We're just going to go through, and if we find no, maybe we do. I was going to say let's just break here, but we do still need to do that. If add And actually, we're going to make this say Pandigital instead of add. Let's use our... And then if Pandigital and int Pandigital greater than largest equals int of Pandigital. Couple other ways we could do that. We could say if Pandigital largest equals the max of the int version. I kind of prefer to do things this way for no particular reason. I'm just kind of used to it. And this needs to be concatenated instead of digits. And then here we just print largest. And let's go back to our problem statement really quick and copy and paste our correct answer just for the time being so we can easily compare it when we do the print here. So problem 38. Okay, Python is not being found for some reason. Okay. So it's coming out as 1, which is not really what we want. Let's add this. If concatenated is greater than 9, then we're going to break so that we stop recalculating things. Okay, so we're obviously getting the incorrect answer. Let's go ahead and start printing out all the things we're getting. Okay. This is very intriguing. Because we're getting true. Ah, that's why we actually want integer of concatenated here, not because Pandigital is my Boolean. Let's go ahead and rename that, shall we? To is Pandigital, so it's obviously a Boolean. Okay, so now maybe we should be getting the correct answer. Okay, and we got the 932,718,654, which is the same as the correct answer. Alright, so this solution is actually slightly different than the one I came up with yesterday. Let's go ahead and look at source control so we can look at those differences. So yesterday I ended up using an array where I saved all of the different Pandigitals. And I actually had a couple extra break statements in here, which one of those I want to put back. Obviously it doesn't really matter because it completed in less than a second, but this seems like better practice to me because we don't want to go through this loop again if we don't have to. But it doesn't actually matter. Now that I'm looking at it, it'll only go through the loop one more time before it's like, well, we're greater than 9, let's just break. So technically more efficient, but like will never actually matter. And previously I had a range of up to 100, but I still got the correct answer using just 10. And I changed the name of this Boolean because this is not a good name, honestly, is the main reason. And I was printing out all of the concatenations that I had found previously. But for this problem, we only care about the largest one, so I actually like the today solution a little bit better. So we've set up our largest equal to true. We go through and find We go through until we hit a 9-digit version. And when we do that, we check whether it is Pandigital by looking for the numbers 1 through 9 inside of that string. If at any point we don't find one, we know that it is not Pandigital, but we set that to false. And I actually think I would prefer to use max here, not lambda. And that way we don't need to have this if check be quite so long, and we don't need to cast this concatenated string to integer twice. And then, of course, if we skip past the number 9, or we get to the point where we're larger than that, we just break out of this loop and go on to the next starting number. So, like, the first number that we'll see here is 1 times 1, so 1 plus 1 times 2, so 2 plus 1 times 3, so we get 1, 2, 3, 4, 5, 6, 7, 8, 9 is our actual first concatenation. But, yeah, I would say that this is actually a slightly better solution than yesterday's, which can happen sometimes. And it doesn't do anything we don't need. It doesn't store information that we don't need. If I add in this break statement here, that makes it a teensy tiny bit more efficient by removing one run of this for loop. But in reality, it's unnecessary. I'm going to leave it in just because I think that is a good idea, but it obviously isn't going to save us very much in terms of time or anything. So, yeah. And that's really it for today, and I'll catch you in the next one.